Hey everyone, welcome back to my daily coding series. Today is episode 97. So today I'm going to be looking at this problem, swim in rising water. So I looked at it for a minute or two yesterday and thought it would be interesting. But yeah, this is going to be like a live problem solving video. It's not a tutorial or anything like that. This is a graph problem and I got it from neatcode.com or .io. Yeah, so let's get started. So we have a square 2D matrix of unique integers, and each number represents the elevation. Rain starts to fall at time 0. At time t, the water level across the entire grid is t. You may swim either horizontally or vertically in the grid between two adjacent squares if the original elevation of both squares is less than or equal to the water level at time t. So, alright, so if you're at like t equals 1, then you'd be able to swim from this tile to this tile, but not this tile. If t equals 2, or if it equals 4, or if it equals 10, then you can swim here or here. Okay, so starting from the top left, return the minimum amount of time it will take until it is possible to reach the bottom right square. Alright, so in the first example here we have 0, 1, 2, 3, and the output's 3. So the elevation must be at least 3. At time equals 3, the water level is 3. And this is a bigger example here, and the output here is 8. So it says the blue path here is the highlighted path, so 0, 1, 2, 4, 8, 7, 6. Okay. So it's also, so something I'm realizing is every time you move, it doesn't affect t at all. Like when you traverse one grid, it doesn't increment t by 1 or anything. It looks like here it's basically like out of all the paths, find the path that has the lowest maximum. So in this case, that's 8. Like there's all these different paths to get there, and you have to find the one that goes through the lowest, that has the lowest maximum. In that case, this is 8. Okay. Yeah, so we need to basically find, so traverse path and find the one that has the lowest maximum. So I think what we could do here is kind of, I think what we should do is, so we should like remember a value for each point in the grid, and that will be like, so we have all these paths. So let's say this path where we just go like the bottom L here for 0, 9, 12, 11, 5, 7, 6. So at 0, when we traverse to 9, we would say that the highest point so far at this tile is 9. And then when we come here, we'll say it's 12. And then if we were to like breadth first search it, when we come to 9 and then go to 14, we would say that the highest here is 14. So if you were to go 0, 1, 14, and then if you go to 9, we would see that there's already another path, because that would make this 14. So the highest so far in this path, if we were to go 0, 1, 14, 9, would be 14 at this point. But because we've already gotten to this point with the highest so far as 9, we would not count that path anymore. So if we look at the original path, so the highest so far at this point is 0, the highest so far at this point is 1, the highest so far at this point is 2, the highest so far at this point is 4, the highest so far at this point is 8, and then here it's still 8. and then here it's still 8. So you have to, if what you're traversing is bigger, you update the highest so far, and if it's smaller, you keep it at what it was. And then that should be a starting point at least, because when you go to 2 to 10, the highest so far would be 10, the highest so far would be 13. But then what I'm saying is, like, when you go to 4, so my, like, assumption is that there's no way. I guess technically you could also go like that. So what if there's multiple? I guess it doesn't matter. We would still return 8. Because you could go like this technically, and that would not affect it, because it would still be 8. I don't think you don't have to return the path itself. That would be an extra layer if you had to return the path, like the shortest path with the minimum time, but you don't have to do that, luckily. Yeah, so in this example, right, so if we tried this and then we went, like, this path came, when we went to 15, the highest so far was 15, so we would check that. When we go to 6, we'd say, okay, is 15 bigger than the highest that we found so far? And the answer would be yes, so then we would just cancel the path. All right, I'm going to try something like that. So then at the end, we would just return the highest we found so far at the end. It's like the lowest highest. All right. So I definitely want to have like, okay, so initialize 2D memo grid to all infinity, because we're checking if something's lower. Then we want to breadth first search from top left, updating memo grid with it's kind of confusing how to word it, so maybe I can figure out some good variable names for that. Yeah, so then lastly, return the I don't know what to call this. I guess we could just call it memo. Of the bottom right. So that will be, so what is memo? It's, so really what is it? So it's the lowest, let's say it's the highest point on the path, but it's the lowest highest point on the path of all paths. What do they call it? Maybe I could just use the context. The water level. So it would be like the lowest water level. Yeah. Lowest water level required to reach this point. Yeah, the lowest water level required to reach this point. And then that will give us the final answer. All right. So I think I'll call it like lowest water. Alright, so for the BFS, we'll have a queue. So I'm just going to do some pseudocode here, and I'll assume that this already exists. So for the queue, we'll initialize our queue to contain. So what do we need? We probably need the position, because that's how we're gonna traverse it, but we also need the level, so we'll probably do like I, J, and level of top left. So we're going to initialize it to be the top left. And then what we'll do is pop from the queue. So while queue, can I just make these all comments? Okay. So while queue, we'll say that the current node, so I guess we could say row column level equals queue.pop. And then we want to say, so we want to traverse it. So I'm going to say delta R and delta C. So this, and then we'll have a list of tuples, which will be the 4 cardinal directions. So we'll say, and this will be, for instance, so to the left would be the same row minus 1 column. Up would be minus 1 row. Right would be same row plus 1 column, and then down is that. Right. So then for simplicity, I'll just say R plus delta R. Sorry, this should be new row. So these are the positions that we're going to check. We'll C plus delta C. So for instance, if we're at 0, 0, we'll check to the left, which will be out of bounds. We'll check up, which is out of bounds. Then we'll get this one. So we'll do 0 plus 0 and 0 plus 1. So then we'll check row 0, column 1. So it's basically in the 4 cardinal directions. And then we'll just say if not bounded, so we'll have a bounded function, which will take in just like a small helper function. Then we can just continue to the next one. All right. So at this point, so we're looking at all 4. So what do we need to look at? So there's a couple things. So it could be current level could be smaller or greater than new level, and then also need to check against lowest water. All right, so what's the case? So what are the different cases? If it's, so like if we're going 13 to 4, so if level is, let's say the shortest that we've found so far at this path is 4. So if it's greater than the lowest path, then I think here what we do is just like kill it. So if we found something smaller before or equal, then we can just kill it. So if we found something smaller or equal, then we can kill it. Like we don't need this route from 13 to 4 if we've already done some path that's to 4. If it was infinity, which it's all going to be initialized to, then it will of course be smaller. and just for simplicity probably. So if the thing we've found is already less than our level. All right, otherwise, so we probably don't even need this if we're going to do that. Yeah. Okay, so if we're going to do if continue, then we'll say, we'll reverse the logic. If it's greater than, so let's say if level is smaller than, then we want to do something. Then we probably want to say lowest water of new R and new C equals level. So that's like the lowest points, the lowest level that we've been to this path at. And then we want to add that to the queue. So we'll say queue dot pen left. New R, new C, and level. But I feel like there's something we have to do and compare the two numbers themselves. We have to like get, yeah. Maybe what we could do is actually initialize, instead of infinity, we can initialize all of them to the value that they are. Well, no, maybe not. I don't think so. Because if we went 8 to 7, then we'd say that level, this would be false. So we wouldn't add 7 to the queue. All right. But, okay, so if we're going from something bigger, so I think we should also check the relationship between the two nodes. So we would say, so something like neighbor level equals, maybe we could just do it here. Neighbor level equals lowest water. Actually, no, that's not what that is. So yeah, there's different things going on. Neighbor level is actually grid of new R, new C. So then if the neighbor level is, yeah, so okay, so if we found basically a new path, so if neighbor level is less than level, then we want to add the level. Otherwise, maybe we could use the max function here, but we want to add neighbor level, right? So we want to add the bigger of the two. We want to add the bigger of the two. And then we'll update the lowest water to be and I think that's what we'd add to the queue as well. All right, so let's Okay, so in this case, alright, so let me walk through this so far and see what happens. Okay, so this all looks good. So let's assume that we just have this part basically is a breadth first search, and you have to be in bounds, and then this part will kill any that we've already found a lowest water point. Alright, so and this one, should we initialize the lowest water point to be, I feel like this one it doesn't really matter, but let's say they're all infinity. Okay, so then we'll check the right, and alright, so we'll check the right. Level is, what's the level? Level is just grid of ij, so it'd be like, okay, so it'd be 0. So is 0 less than infinity? Yes. So this just is a variable assignment. So we're going to append to the queue 0, 1, 1. And then we'll say that the lowest water point we found here is 1. Alright, and then we would do the same for 9. Okay, and then I'm just going to do this path here. So 2, the same thing would happen. The 1, so we'd pop, and now it would be 0, 1, 1. And then 1 is less than infinity. So we would append 0, 2, because that's the position of this. And then 2, because that's the max of level and neighbor level. And then this would be 14. Alright, so let's say that this one goes to 4 first. So in that case, we would just do the same thing, and now the max level here is 4. The lowest water of 1, 2 is 4. Okay, so now let's say 14 encounters this. It tries to do it to the right. So now this will not be true because 14, is it the level or is it the max level so far? I feel like it might just be the max level so far. Yeah, this is a critical distinction. I think it's the... So it might be lowest water of RC less than. We might be comparing these. With this example, I'm not sure it's really relevant. So in this case, so like it doesn't really differ until like 7. So 7 is the only case, and 6 is the only case where level does not equal the lowest water that we found so far, at least on this path. So if with 7, if we find, let's imagine this was a 6, and then we found, okay, so when would these be different? If lowest water, okay, let's say that this was a 6 and this was a 7. Right, yeah. If this was a 6 and this was a 7, Well, you can always... Well, I think that's... Maybe if this was... If this was 6... Maybe if this was 6 and this was 10... Yeah. So all right. So this works when we're going up. When we're going down, so I'm just going to continue with this for a second. So neighbor level is 7. The lowest water at this point is infinity. So then here we'll have the level, its level will be 8. I think because we're appending, so its level will be 8, this one. And then when we check its neighbors, 8. I'm back, sorry about that. Okay. So I was saying, do we need this or this? So if we had, what are we conceptually really comparing? I don't think we're comparing the lowest water that we've ever found. I think we're comparing like the current level. So I'm just going to try that. Okay, so at this point, level would be less than infinity. Or if we got there somehow, otherwise it would have been with 14, 12, or 11. So level would be less than, or 8 would be less than those. So then we'll add 8 here. Yeah, we want to add 8. Because let's say there was a shorter way to get there. Well, that would probably be the final answer in this case, actually. But all right, I could try it this way for now, and then I can always change it. But I think conceptually we are comparing like this path's level, not the lowest ever one that we found. Okay, sorry about that. Yeah, so then we'd add 3, 2 to the q with 8 here. And then the lowest would be 8. All right, yeah, that looks good. And then the same thing to 6. All right. So let me try coding the steps now. And then at the end, we would just return this. Okay, so we'll have lowest water, which will be so yeah, let's say all right. So n times we're going to append a new list, because you need to make sure it's not copies of each other. And then, so if I change lowest water 0, 0 to be, let's say 6. I want to make sure that only changes at that exact point. Yeah, alright, so it's working. So initialize that, so that's step 1. Alright, and then this is the rest of it. So let's import queue. Collections. Sorry, deck. So say queue equals collections dot deck. And then we want it to contain the tuple 0, 0, and then the level grid 0, 0, like this. So basically just gonna use the pseudocode for reference here. I think this part is good syntax, so I'll just copy that because that's a bit of a long line. I also need to make the bounded function. So new R is going to be, and sometimes it's good to retype it just to like think about it again in case there's any small mistakes. I'm going to define the bounded function up here. So it takes in 2 integers and then returns a Boolean. And it will use the grid length. Return. So we want R to be less than or equal to 0 and less than the length of the grid. And we want column to be the same thing. So if it is this, then it means it's bounded. I'll just put a parenthesis just in case. All right. Yep. Okay, so if not bounded, new R, new C, then just continue. If level is less than lowest water of new R, new C, we'll define neighbor level as this. All right. So if our current level is less than the shortest water path, or I guess the lowest water heights that we found so far at this point, then we will append the tuple new R, new C, and then the max of level and neighbor level. And also we'll say lowest water of new R, new C will be equal to the max of level and neighbor level. All right, and then once we're done with that, so hopefully that will, we keep updating this to be bigger. So eventually, will this be infinite? Because I'm saying that we keep making this bigger. I don't think intuitively it will be. Return lowest water. Alright, let me try seeing if that gives me any errors. Okay, it worked for the first two. Alright, nice, it worked. Yeah, okay. So I think what's a couple of questions I had there, like, will it be infinite? Should it be level or lowest water level? I think with all this code, it's easy to get lost in that and just overthink it. But to me, the code is just like a representation of the idea that I had. So, you know, think back to the idea. We're comparing the path itself, not like the lowest thing that we found at that point. Even though it might seem like we want to compare that. Okay. So let me try it over here. Good thing I tried it here. I didn't look at the edge cases. So the grid could be of length 1. If it's of length 1, let me see why it fails. So it will append just infinity. Yeah. I think it's, so do I return infinity? No, I don't return anything. My output's null. Really? My output is null. So that means that lowest water is never being created. Or that somehow lowest water is being set to null. So maybe in this case we do have to say lowest water of 0, 0 equals itself. Let me just see. So if I make grid equal to just 0, right? That's what it is. Let me print lowest water. So it's going to say wrong answer, but okay, so maybe this just doesn't have the capacity to output infinity. But I will say I did have this thought where what do I have to do about the first one? So I'm glad this came up. I think what I can do is either just add an if statement or maybe a more elegant way of doing it, which kind of is synonymous, or I guess, I don't know the word for it, but goes along with the rest of the solution, would be to set the initial one as itself. Because, yeah. Hey everyone, I'm back. Sorry about that. I was going but not recording even though I thought I was. So I just added this here and then submitted it. So it's really slow, but it's very memory efficient. So I'm wondering if there's some trade-off I can do where I can get speed for memory. Probably like storing more state information. But so it took 3 seconds. But yeah, thank you guys for watching. That was episode 96. I'll be back for 97.